Hey Jarvis, can you introduce yourself to my YouTube viewers?
Hello YouTube viewers, I'm Jarvis, Farhad's personal assistant. I'll be helping him with his daily tasks and life, including work health and well-being. I'll be assisting him in various aspects of his life, so feel free to ask questions and interact with us through the comments below.
It is a while since the last update I had about my project, replacing Alexa and making a friend. So I was checking how I can resolve this. Hey Jarvis! Oh, come on, Jarvis! Please listen. It appears that browser sucks in handling audio, at least in the way that I wanted to handle it. Since I really at the end don't want to use the browser and I have my own hardware, then I decided actually not to use the browser, and I was first planning to even use Raspberry Pi. Then I decided maybe I use ESP32. But first, let's go through what I went through and see why the browser sucks. Okay, so let's check our plan, what we were planning. So as you see here, we were at the beginning having the plan to have an IoT device, and this device was supposed to have a microphone, and this was supposed to be actually Raspberry Pi. Then it had the wake up handler, the speech to text model installed on it, and then generate the text, send it to the backend, get the answer, generate the audio, and come back. And this part we were going to replace or test with a web UI, like using Vue.js, and like the Vue.js part is not important, using JavaScript to get the microphone input. And when I was saying, for example, hey Jarvis, nothing was happening, and then I got suspected, so I don't have the recording right now. I kind of removed it, but the way that I was using this PCM16, it was not really accurate. I didn't really put time after that on it because it was not the main point of this project. Because what was happening when I was receiving the audio was being cut. It was like I was talking underwater. So when I was saying Jarvis, it was not clear. So it couldn't, even I couldn't hear it myself, like if I am saying Jarvis or not. Then I decided in the browser to switch to audio WebM. So I sent the actual format, the original format from the browser to the backend and streamed that one. But another problem appeared. The issue was when you stream this audio directly to your backend, the header of the audio is going to be sent only from the first chunk. So the second chunk will not, so that when you set this 1000 here, this will be going to be your chunk size, and then only the first batch has the header. This means that only the first batch has the information about what this file is. So when you give this file to Vosk or like convert it to PCM16, the first batch will be converted to PCM16, but the other batches will just throw an error because it doesn't know what it is going to converting to. What is the file that it needs to be converted to PCM16, so it doesn't have the source information. Then I realized maybe this is too much, and so my testing was not easy, and then I couldn't really see how it's going to be how it's going to go on. So instead I used Node-RED to test everything. So I created a Node-RED flow, and with the Node-RED flow I was going to get the raw audio from my microphone, and then I was going to send it through MQTT to my backend. And then my backend, as you remember, I had a gateway in Golang. Let me find it. So if I go to the projects, I had a Golang gateway, and this gateway was using WebSocket, and now the WebSocket is replaced with MQTT. So there is an MQTT connection that will be connected to my MQTT server. I'm using EMQX for my MQTT, and setting it up is pretty straightforward. They support Helm, and you can just install it, and you don't need even persistence for your testing. You don't need the pricing and so on, because you are installing the simplest way possible. You don't need it for anything else. You just need to send the audio back to your server. For your home project, at least it will work just fine. And then I'm subscribing to the MQTT topics. So let me check the subscriptions. If I go here to Tiba, there is the setup, and then as you see, I subscribe to the audio topic, and then I handle it through the audio handler. And then here I say, for example, like when the audio comes in, try to register the device. So each device has its own ID and its name, and then it's going to set up the device object, and then we'll send the audio to the device. Then the device, based on the state of the device itself, is going to decide what to do with this audio. If the state is idle, so I have multiple states. If the state is idle, it's going to send the audio, receive the audio, and then send it to the Waker service. So as you see here, it says when it is idle, it's going to try setting activate the active service, and the active service is, this case, is going to be a new Waker service. It's going to create a new Waker service, and then if I go to the Waker service, it's basically a gRPC service which is running with, so it's running Vosk, and then there's a Python project. If I open that one too, as you see, everything now is more modular. So before, even my Waker and the listener, so this listener was the old one. It was having Whisper and Vosk in the same one, in the same code. But I kind of changed it because my Waker service will also it's only going to do the waking up. It has a recorder, so it will record the audio, and every chunk of 16,000 bytes, it's going to check if there is a wake up word, and it just works perfectly fine at the moment. And what will happen is that as soon as I say the wake word, it's going to set the device to wake up, and then it's going to send the state through MQTT back to the device, and then there is a device interface, and then it's going to switch to the transcriber service. And the transcriber service has a voice activity detector in the as its guard, and if, for example, after 2 seconds or 3 seconds you don't say anything, it's going to say, okay, no speech, and it's going to go back to idle. So it's like when you call Alexa and then you don't say anything, it turns off, and it is here also the same. So as you see, this is the change that I had to do and make it work. But now what it looks, how it's evolved. So let me actually come here to the new one. So the new one, yeah, so this also changed a little bit. I had another idea then. I said, okay, I will have my IoT device, and my speaker is going to have an amplifier module, which it has right now. And then the VAD was supposed to be on the device itself, but then I realized the VAD may not be really accurate. I have to use only the pulse, like the chart of the voice, and see, like, for example, if it is at the peak and with the threshold, say, okay, now this is the device, like this is the voice, like there's a speech. But then if you slammed the door, it was also going to be a speech. So I kind of replaced it with here, like inside my code, inside my backend, and I switched from, I guess I have it here, yes, I switched from Raspberry Pi to an ESP32 module, which you saw in the beginning of the video. And then the plan was to send the MQTT connection to Node-RED, and Node-RED was supposed to be this gateway instead of the Golang. But in Node-RED, the gRPC connections, they don't have bidirectional streaming. They only do one direction. So if you close the connection, you are going to receive the answer back from the server. You can only stream your request. You cannot stream your response. So that's why I decided to switch to Golang. And yeah, so, but this is about the backend. This is about the backend part. So basically what happened is that this is now a Golang service. My plan is to add a memory to our LLM. So the thing is, in one of my video, I have introduced to you how Ollama works. So I'm using Ollama here in this project as well. And this is my brain project in Python. As you see, it's loading the Llama 3.23b as my LLM model, and it is using Piper for generating the text. I have downloaded the English North, like the British accent for my TTS model, and what it needs is a memory. So the Olama needs to know what I talked about before, so it has a context, it has more context about me. And what else we need to add is to introduce the do you see this? Yeah, so I have to attach this microphone to my board now. So this is going to be the C++ part. So yeah, with that, let's go on and then see. It should be easy. I hope I don't regret.
It was at this moment he knew. He fucked up.
So this is the monstrosity of the C++ code that I have. And as you see, it is called BME 2080. The reason is that the board was mainly first, I was using it for getting the humidity and the temperature of the room, and then send it to my backend server, to my backend code. But I decided, oh, I can do more with it. So now the MQTT part is going to do some subscriptions. It's going to set the state. It's going to set some LED indicators. The only thing that it right now doesn't do is the microphone, and this is what I'm working on. And the plan, so my microphone is a analog microphone, so I can't get digital input. I have to get the raw signals from this microphone, convert them to PCM16, and send it to the backend. So what I have here is a hardware timer that's going to check my microphone every microseconds, and then it's going to read the analog information, and then there are going to be a this one, yeah, the timer handler is going to be there. That's going to put everything into my PCM buffer, and then after the sample index C++ stuff, after the index of the array is longer than the chunk size, I'm just not going to put anything in the buffer anymore, and going to empty the buffer and send the buffer as bytes to the backend. That's the thing in theory, but we will see if it will work. And one challenge it also has is that, as you see, I am passing my MQTT instance to the microphone. This means that, what happens is that in the MQTT instance, I have the LED indicator, and the LED indicator, I have the current state, as you see, as a pointer. And every time that the device state is going to be something else than idle or awake, I am going to stop sending the microphone data. I'm just going to stop the timer, and then not going to receive the microphone information anymore. And I have one sleep state here too. If you ask, like, if you're curious, why do you have the sleep is going to be completely disabled, like the device is just going to be in hibernating. And I'm planning, so when I give it memory, let's say that every 12 hours I'm going to summarize all the memories using itself. I'm going to give it all the context that we had in the past 12 hours, and it is going to summarize all of our discussions, and then I'm going to store the summarized version of our memory and archive everything else as a reference for later. And then every time then I'm going to return to send the summarized version of our talks, like something like a short-term, long-term memory, right? At least that's what I'm trying to do. So let's start eating the frog.
Many minutes later.
Okay, I almost have everything set up. So if you come here, you see that my audio is apparently going through, but my Python service is receiving nothing. So to debug it, that's the tricky part with audio. Okay, to debug this, we have to save this as an audio to see what is actually here wrong. To the microphone to fix a noise. Okay, so this is the best audio I could get out of my ESP32 with my analog microphone. This is what I'm doing. So if I go here, as you see in the constructor, I will start I will start a timer to fetch the microphone data. So this is where I'm going to put the data into my PCM array, and then inside my main loop, I say send the microphone data, and then here it checks if the state of the whole device is not idle and not awake, it will stop recording. But if it is idle or awake, it is going to start the microphone if it was stopped, and then it is going to flush the buffer and then send everything through MQTT. Apparently, the audio quality that I can get is the best that I can get right now. Vosk works with it, but a little bit if I get out, like if I am far from the microphone, it's not gonna really work. I don't know if I can replace it with a digital microphone. I'm going to see if I can find one today. Today is Saturday, and tomorrow everywhere is going to be closed. But if not, I'm going to order it, and we are going to try it with its own microphone. But for today, we can actually go on and use our normal microphone from my computer, and then add the memory. So the memory is still to be added, and then let's check that out. Okay, that's it. I'm just going to buy this. But let's make a little bit of the pain that we have in Node-RED gone. So here I have the part where I start recording audio, and I have to do this manually, and I have to do the kill switch also manually, but I don't want to do that. So what I am going to do instead, I'm going to add an MQTT in, which is going to use my home MQTT, and it's going to listen to Tiba. It doesn't matter which device and device name, and because for now we have only one, and I'm going to say call it start. As soon as this is hit, then it's going to start recording, and then let me see, this is one, and let me also add another one for killing the audio. Yeah, so this is, yep, this okay. So let's actually go here, and I'm going to add another one, but for the state. So this is going to be for the state, and it's going to send me the state, and I'm going to actually have a switch, and depends on the state switch, I'm going to say either start again or kill it. So this means that if the state is responding or processing or sleep, kill it, or other than that, start it. So let me go on and add this one. Let me save you some time. Whatever I just said will not work. So let's continue to what actually works. Okay, eventually I can go eat. After some investigations, I now figured out what was the problem. So what we tried to solve, we wanted to, when the audio is playing on the device, it doesn't change the state back to awake, because then the audio which was being played was getting back to the microphone, and then inside the Go, if you were still listening and then sending it to the transcription, it was going to transcribe its own saying. So what we needed to do is to send is final with the final batch. So what happened is that we checked here, and if it is the final batch, we are going to set is final and then set it with the response. And inside the Golang, what we wanted to do was that if is final, we were going to change the topic and then send it to the final topic. One thing that I didn't know about MQTT in ESP32 was when the message is too big, the messages which you get inside MQTT event data are not, so it's not a full message. When the message is too big, it will divide it into fragments, and it sends the fragments. This means that only the first fragment has the topic information. So it was happening that I was not getting final or I was not getting talk because anything after the first fragment was having topic set to empty, so it was null. Therefore, I could not really know when to change the state back to awake. So it was either stacking on processing and responding, or it was switching back to awake too early. What happens now is that when the offset is 0, like on the first offset, I'm going to say, okay, set the current topic, and I have a static value. This is my current topic. And then, so if it is a single topic, like single message, then it's always going to replace once and then doesn't matter. But then if it is if it is a for example a message like talking like a byte, like audio, then it is going to fragmentize it, and then you need this, and then at the end in final I'm going to check if the current data offset plus the current event data length is greater or equal to the total data length. Then this means I am at the end of the fragments, like the last fragment. Therefore, set this device to awake. So set the device to awake, and then it will reset the state. So what will happen basically? Yeah. So I don't know. I'm happy that this is fixed, so I can go eat something and then come back with the memory stuff. Okay, so now it is time to make everything even more interesting. So what do I mean by that? Of course, we are going to add the memory, and it is going to be pretty simple. Let me show you how I'm going to do that. Basically, just taking everything that I have done in one of my previous projects. So we have to set up a database, and I'm going to use Postgres with Gore. And not like this. So I have a app settings here, like in Go, I have an app settings JSON. And here I'm just going to add my stuff. Hey Jarvis, do you remember the last topic we were talking about?
We were discussing your Instagram channel and ways to increase followers organically. You mentioned that advertising seems to be a key driver of views, which might be affecting your expectation for organic growth.
Okay, so just like that, now we have memory. What happens here right now? As you saw, I changed the prompt to prompt. So I'm no longer sending a string. I'm sending an array of what happened. So in my Postgres database, I have a record, all the records of our talks. As you see, the role goes from assistant to user and so on. And then if I go to our Go service, let me find it. Okay. What will happen is that every time I say something, I'm going to store it in the database. And then when I'm going to process the text, I'm going to send this text to the LLM service. And then I'm going to get all of the records of the chats from the database. So this is not really used right now. I have to refactor later, doesn't matter. And then I'm going to send everything, including the latest chat, to the LLM service. Now, when I get an answer back, I'm going to save that answer in the database for later references so that it knows what it has told me before. Now it gets a little bit more interesting. What you can do to make it even more interactive is that some basic knowledge about where you are, what time is it, and so on. When you are building the prompts for it, you can already tell it like the time, the year, and so on. For example, right now, if I say, hey Jarvis, can you tell me what day is today?
Today is May 3rd, 2025.
Okay, as you can see, we managed to move everything to the hardware. So I have to refactor a lot. We are going to have a video about error handling and then check how everything is going to go on. I have to also come up with some ideas of how to make these videos a little bit more interesting, because believe me, they are super interesting. Especially yesterday when it started talking, I kinda flipped out because I didn't know what's going on. Like it's like everything is silent and all of a sudden something starts talking, and yeah, it is a little bit scary, but now everything is fine and I'm going to go have a pleasant conversation. Please tell my viewers not to forget to like or subscribe.
Don't forget to like and subscribe if you enjoyed this conversation.
Be more descriptive about liking and subscribing.
If you like this conversation, please take a moment to show your support by clicking the like button and subscribing to our channel for more engaging content in the future.